Welcome to Machine Learning Lesson 4.7. In this video, we're going to go through an example of using the k-nearest neighbor classification algorithm to predict if we would have survived the Titanic. In doing so, we're going to go through the development cycle, and you're going to see the similar steps that need to be followed regardless of what type of machine learning algorithm you're using. So let's talk a little bit about the data set. So the Titanic was a luxury cruise liner that hit an iceberg, and a lot of people did not survive, but some people did. So we're going to use the k-nearest neighbor classification algorithm to determine our likeness to people who survived or did not survive the Titanic, to determine if we would have survived the Titanic. So let's get to it. So the first step in any machine learning algorithm is to load your libraries. So we got the pandas, we got the matplotlib, and now we get into the scikit-learn. So this is where it will differ a little bit depending on your algorithm, but you're going to find that the step is very similar. We got to load the right object from the right module in the scikit-learn. So if you were doing a linear regression algorithm, you would have loaded linear regression from the linear model module. Well, since we're using k-nearest neighbor, we're going to load up the k-neighbors classifier from the neighbors module of the scikit-learn. Again, a lot of this stuff you can simply look up, but it is an essential step. The next part, which will be pretty much the same regardless of which machine learning algorithm you use, is the train test split. Obviously, it's a very useful function to split up our data into a training set and a testing set. The next one, it's new to this, is the standard scalar. As we talked in a previous video, k-nearest neighbor uses the distance formula to determine its proximity to other liked items. But we saw that when you have features that are at different scales, ones at higher scales will overshadow the ones with smaller scales. So to give each feature equal weight, we have to scale them all to the same, roughly the same area, so there is no overshadowing of features. And that's what this particular object will do for us. We've seen the use of NumPy in the past in data cleaning. We're going to see a different use of NumPy in this example in terms of being able to represent our information. Don't forget that whenever you look at an example, even if there is output, you must run it. Again, I'm notorious for seeing output and just kind of going through the flow of it, but not realizing I actually have to run it if I actually want to have the data set and the code available to me later on. So we load up the data. Let's take a quick look. So we see passenger ID. That's just an ID, nothing special there. Survived is zeros and ones. 0 meaning you didn't survive, 1 meaning you did. P class represents where you were in the ship, whether you were first class, second class, or third class. Name, nothing special there. Sex, male or female. We're going to do something with this later on because we can't use text information in a distance formula. So we have to represent this some other way. And then we see an age. We have some other features that we're not going to use as part of our prediction of whether we survived the Titanic or not. But we will use survive, P class, sex, and age. So usually the first thing you do after loading your data and taking a quick snapshot is to do a describe. Again, it's a very useful function, though in this one we might find that it's not going to be very useful. For instance, for passenger ID, survived, because of the fact that it's the mean, min, max, it's not showing us a lot of good information here. But the one thing we will take away from all of these is that there is 191 different rows within this data set. When we get to age, this is the first step where we're getting something meaningful. We can see that the average age of a person on the Titanic was about 30, with the oldest person being 80, which in those days was an old person, a very old person. And then we have the youngest person being 0.42. And you might think, oh, what's a 0.42 age person? Well, that's a baby, somebody who was younger than 1. So again, this was a little bit useful, but something that might help us get more insight into the data set is to perhaps do a histogram. So let's do that. So let's do df hist. And let's change the fig size a little bit just in case they turn out to be small. We'll do a 1010 for fig size. And let's see what we're getting here. So as we mentioned, passenger ID is not a useful column for us, a useful feature. It's just unique identifiers for each person. But when we get to this one, we're seeing some information that we did not see in the survived, which is how many people died and how many people survived. So, we could kind of estimate about 340 survived and about maybe 570 did not survive. And obviously the sum of these two needs to add up to 189 because everybody in this data set either survived or did not survive. Something else we can kind of get further insight is the P class. So we can see the number of people that were in first class, second class, and third class. Third class, those are the people that are very bottom of the ship. So there's definitely a lot of people here. These were the poor passengers. So again, just an understanding of the data set. And again, these numbers also would add up to 891. Going into our last feature that we want to use as part of our prediction is age. So we're noticing a very tight group here. We saw that the average was about 30. And you can see it's a good distribution where a bulk of the passengers were in this area, and then it slowly kind of tapers off. We're going to use this as an understanding for later on when we try to clean our data. So now, while we're there, cleaning our data, it's the next essential step in our development cycle. We got to make sure we're working with clean data. So let's run this. And we can see here that we have 177 rows that don't have an age. So, one thing we could do, we could drop those columns, those rows. But again, we're dropping a lot from our data set. We only have 891 to begin with. So instead of dropping, because we have such a tight grouping of the age here, it might make more sense for us simply to fill in any missing age with the mean. Now, is this a perfect match? No, but it will allow us to at least include those rows. And because of the distribution, it's not going to affect us too much. Is there some effect? There will be, because it's not actually their age, but it'll allow us to be able to continue on with our machine learning application. So we've cleaned up our data. The next thing would be any kind of transformation that needs to happen in our data. So as we said earlier, sex right now has male or female, which we can't use as part of our distance formula. So what we're doing here is that we're going to enter in a 1 in the sex column if the person was a female. Otherwise, we're entering a 0, which means a 0 is a male. So this will transform our data into something numerical that we can now use the k-nearest neighbor for in terms of figuring out a distance to somebody else who's either male or female. The other thing that's important, again, continuing on with our understanding of how we need to transform our data, P class has 3 groupings in there, 1, 2, and 3, which might not necessarily have a direct relationship. In this case, I kind of do feel it does, but it's almost like a reverse relationship, where if we use the P class by itself, people in third class would have a higher distance than people in first class. Again, 3 squared as compared to 1 squared. Again, the 3 squared wins, but it's kind of like the reverse. So we want something that we're able to kind of grasp whether somebody was in first class or second class. So when you have categorical data like this, it's often best to split the categories into their own columns and then use kind of like a flag. So that's what we're doing here. So we're going to create a column called first class, that if your class was a 1 in P class, we're going to enter a 1 here. Same thing we're going to create another column for second class. So if your class was a 2 in the P class, we're going to enter a 1 in this class. So let me run this, and let's do a DF head, just so you kind of can appreciate what's going on here. So you can see here for the column sex, we no longer have male or female. We have zeros and ones. Again, something we can now use with our distance formula. And we have these two additional columns, first class and second class. So let's see how that relates to the original data, which was a 3. So notice how I'm not in first class because there's a 0. I'm not in second class, which is a 0. So that is enough information for us to determine that I must have been in third class. So it's just a different way of determining what class you're in. But here's the benefit of this. We can now use first class as its own predictor, as its own feature. We can use second class as its own feature, instead of also having third class be part of the mix. So again, you'll get more practice of this idea of splitting categorical information into separate columns if you further explore k-nearest neighbor. Now we get into something that becomes a little more familiar. So now that we've prepared our data, we are ready to get into that final step of let's extract the data so we can create our models, train our models, and evaluate our models. So let's run this, and as you can see here, we're going to use sex, age, first class, and second class as our predictors with the k-nearest neighbor, and survived is our target. We split up our data into a training and testing set, and this is a necessary step. So we talked about how certain features are not on the same scale. So within these now, if we scroll up a little bit, we can see here that sex is 0 or 1. First class is 0 or 1. Second class is 0 or 1. But age now ranges from 0 to up to 80. So age would overshadow the other features that we're using as part of our classifier. So we're going to use the standard scaler to scale the training data as well as the testing data. So let's do that. And let's just take a quick look at what's actually being stored in xtrain now. So you can see here, it's taken those features that was zeros or ones, 0 to 80, 0, 1, 0, 1, and it's put them all in some kind of similar scale so that the age does not overshadow the other ones. Again, don't try to understand the numbers. Just realize that somehow they've been scaled appropriately so we can now use the k-nearest neighbor classification. So I'm going to get rid of that. And now we get to the easy step. Again, data preparation is the most important step in machine learning algorithm, the development cycle. You have to have good data before you can actually train your model. But once you're ready there, the library, the Python scikit-learn library, will do all the heavy lifting of actually doing the algorithm, of the distance formula amongst all the different features. So here we go. So we're creating a variable for our k-nearest neighbor classifier. We're choosing to use 5 neighbors. Again, this is something that you can, later on with a for loop, try to figure out, what is the best number of neighbors to use that will get me the best score. And we'll see that here in a second. So we create our object and we train our model. That's it. I mean, I love this step right here. Because all you're doing is just taking the data that got split up and just fit it to the model. So let's run this. And now let's go ahead and evaluate. So you can see here, wow, our score has increased by a lot. So, we got an 83 and 85, which are very good scores for models. And that's it. So, I mean, these 2 steps is the actual creation, training, and evaluation. So now we're ready to actually use our model. So what I've done here is I've created, using NumPy, a couple of arrays with values for each of these categories that we're using in our feature, each of these features. So Jack, he was a male, so he's 0, age 20, and he was in 3rd class, so he gets a 0 and a 0 for 1st class. Rose, on the other hand, was a female, so she gets a 1. She was 17, and she was in 1st class. I decided for the fun of it, I put myself and my wife in here, just kind of see if we survived the Titanic. So you can see here I got 0, 47, and I'm down in the dumps. I'm 3rd class. My wife, on the other hand, though, she's a female, 39, and we got her into 2nd class, save some bucks for her. So I create another NumPy array of all the passengers. So this is kind of nice. This is very readable. And then I transform all the passengers in one shot. I could have done this part individually for each passenger, but it's just nicer to kind of group everybody together. And let's go ahead and run this, and let's see what happens. So we can see here that Jack, being the first person in the passenger array, did not survive. Rose did survive. I did not survive, and my wife survived. So again, if you know anything about the movie and about the history, women and children came first. So one of the things I had fun with this, in terms of Jack and I are both in the same boat. We're in 3rd class. So I tried to go down even further, run it. So let's say I was 15. I still did not survive. Let's say I was, I think 10, because I've done this before. No, 10, I still did not survive. Let's see, 9. No. Wow, so even a 9-year-old male in 3rd class did not survive. Wow. Okay, let's go all the way down to 2. A 2-year-old. No. Okay, so if you were in 3rd class, sorry. You were not getting up there. But the other interesting thing, too, is that let's say I decided to promote myself to 1st class. I sold off some bonds. It didn't matter. Again, a large majority of the passengers that did not survive were male. Again, because the whole, women and children first were loaded up onto the lifeboats. The males were the last ones to survive. And again, if you were down in 3rd class, you weren't going. Kind of curious. If I was a male 20 in 1st class, did I survive? Nope, still nothing. So anyway, hopefully you've had some fun with this. Let's go back to our presentation. So K-nearest neighbor classification is a great way to predict an outcome based off similarities with other known data points. So in this video, we saw that we looked at the Titanic data set, and we compared our likeness to people who did survive or did not survive the Titanic to determine if we ourselves would have survived the Titanic. So I look forward to seeing what you can do with other data sets and using the K-nearest neighbor classification algorithm. Enjoy.